Okay, from first principles, they are asking us to find the derivative here by using first principles. Okay, so f prime x by using first principles, and they've given us a nice function that we can use. Now remember on your sketchboard, remember what is first principles, a reminder. It's a first derivative which is taken by the limit when h approaches 0 of your average gradient, f of x plus h minus f of x, all of that over h. So do it bit by bit, because if you make a notation error, you are going to lose some serious marks here. So let's look at 7.1. The limit when h approaches 0 of f of x plus h minus f of x, all of that over h is what we're looking for. Then we have the first derivative. So let us start and let's say, okay, we've got f of x. F of x is given as 2x squared minus 1. F of x plus h is what we need. So that will be twice. Now remember, every x gets replaced by x plus h, all squared minus 1. Now if I multiply that out, I get twice x squared plus 2hx plus h squared minus 1, and that gives me 2x squared plus 4hx plus 2h squared minus 1. That is quite nice. I squared the binomial and I multiplied in. Now I can find the gradient. F of x plus h minus f of x. All of that divided by h is then this 2x squared plus 4hx plus 2h squared minus 1 minus, and this is where I want you guys to get used to using a bracket. You're going to subtract this 2x squared minus 1. And that negative is going to influence the sign of the minus 1. Okay, so if we do that, we get 2x squared plus 4hx plus 2h squared minus 1 minus 2x squared plus 1, all of that divided by h. And this is where you check yourself whether you are correct. There's a 2x squared minus a 2x squared. There's a minus 1, there's a plus 1. So whatever you are left with will have to have this h. Okay, so we remove the common factor. We get 4x plus 2h. All of that divided by h. The 2 h's cancel. And now I'm ready. I can say my first derivative with respect to x is the limit when h approaches 0 of f of x plus h minus the f of x, all of that over h. That is equivalent to the limit when h approaches 0 of this 4x plus 2h. Remember to put it in a bracket. The h becomes 0, and that limit is 4x. So by first principles, you showed that the limit of f of x equal to 2x squared minus 1, if I differentiate it, gives me a derivative of 4x.